Welcome to the fish tank.
Hey everybody, Fishman here. Welcome to a new video series I'm going to be doing. This is my old belt sander, and I'm going to build a new one to replace it. I've had this one forever. It's over 20 years old, the switch is broken, and I don't actually use it that much anymore. Mostly because I do a lot of aluminum work now, and as you can tell, it's hard to get the inside corners sanded properly with the small round wheels. I originally just used this for arresting glass when I was doing a lot of small builds in the beginning, but most of my stuff now is more custom work for larger tanks, and I don't really need it much anymore. But I just got a new job, and the new job is to build a large 3-tank system, which is all going to be interconnected. It's going to be kind of cool. There will be a video for it later on as well. But what I need this new sander for is I'm going to have to do a lot of aluminum work. And I've been on the internet a lot because, you know, I've just started doing my own YouTube channel, and I checked out a lot of other people's works, and apparently the most popular thing is a 12 by 72 belt sander for doing, well, lots of different things. But I've checked out a bunch of videos. I've never built one before, so I thought I'd give it a go. I have 2 weeks before I have to start the other build, so if I can get this done in that time, that'd be great because I wouldn't have to buy one. Otherwise, if this doesn't work, I'll be going out and buying a belt sander. And as in my previous videos, we'll start off by going through all the raw materials. This is going to be mostly out of aluminum, except for that rod you just saw me move, which is 1/2-inch threaded steel rod. This is 2-inch square tube aluminum. It's got 1/4-inch walls. It's more than solid enough for me to use for the framing and basically hold all the wheels in their respective positions. The piece of aluminum rod that's stuck in the track of my table saw there, that is going to be used to make the spacers to hold the bearings in place, and that will fit onto this threaded rod and be held in place by the bolts. But that's for the next video. This video is all about making the drive wheel, which will be made out of that larger chunk of aluminum that is solid 3-inch diameter, and I'll be cutting a 2.5-inch buck out of it like this. And I'll be joining that onto the drive wheel of this old motor I have. I didn't want to buy a new motor because that's going to add like $200 or $100 depending on the quality of the motor. So I just going to use this old one. It's got nice smooth bearings, so it should be more than good enough for this project. And the last of the raw materials will be the base plate for this whole belt sander project, and that would be this 1/2-inch piece of aluminum. It was basically an offcut from where I pick up all my metals. I took it as is. It's a bit longer and wider than I require, but it's cheaper to get it this way than it is to have them cut a specific size for me. So that's enough of the raw materials. Most of this actually not even going to be used in this video. They're all for future videos. All I'm going to do today is work with this puck of aluminum. As you can tell, the video is now moved into fast forward. It'll help speed things through, because otherwise it's like maybe 35 minutes of me machining aluminum. What I'm doing here is I'm just going to face both sides of this and then drill a hole through it. So the facing is just so I can true up the ends and, well, make it look nicer, because it is kind of rough with the saw cuts, and this just makes it nice and smooth and makes it easier for me to align where all the holes are going to be as well. There you go, fast forward, it doesn't take long. One side's done, I'll just flip it over and do the other side now. When I do this side, I will leave the center section, like basically smaller than the hole I'll be machining. I'll just leave it raw because it's flat as it is. So there you go. It's easy to see that way. It's just easier for me to work with because it's a nice flat surface right there, and I'll just center up the drill bit, which is the drive shaft for the motor is 1/2-inch. This drill bit is 3/8. So I'm just going to cut a rough hole here at this point. And then once I have the hole done, I will use a boring bar, and I will make an accurate hole. So I have basically a friction fit hole. If you're wondering why I always use aluminum in my projects, is you can't really tell in the background there, but my shop has a lot of aquariums in it, and the extra moisture in the air tends to cause a lot of other things to rust. So you know, after 10 or 20 years, even if you take care of things properly, you know, it does tend to have a little bit of wear and tear, as you can tell on my lathe here. So I tend to make a lot of stuff out of aluminum. Hey, fast forward boring bar. It looks really stupid this way. But basically what I'm doing here is I'm just widening that hole until I get to a diameter that I want. And once I get close, as well, you can't really tell, but every time I go in, I'm doing incremental increases in diameter. Looking at the dial, I can tell how far I've gone. And what I'll do is, as I think in this particular video, there'll be like 3 stops. And I'll just double check, because as I get closer to the final diameter, I'll slow down on how my increments, making much smaller passes, because I do want this to fit as tightly as possible. And even though this puck of aluminum is probably only worth like $6, I don't really want to waste pieces, because then it'd be cheaper just to go buy a sander. Getting closer. It looks so funny that way. Alright, this should be the last pass, I suspect. Yeah, I'm taking very little off now. All that's left on there is the old pieces from the last time. And yep, we're done. So I'm just gonna wipe that off. And fast forward showing of a hole is really silly. I won't do that anymore. I didn't go all the way through. As you can see, the diameter of the holes are different on either side, because first off, my boring bar isn't that long, and I didn't really want to buy a bigger one. But I only needed to go in a certain length to basically where the key slot ends for on the shaft. So I just wanted to make sure I had a sufficient amount. That's what this part was for. And it fits very snugly. But you notice the shaft is like, this motor's old, so it has a lot of rust on it. And what I'll do is I'll probably just sand that down a little bit to first off clean off the rust a bit, and also it'll slow reduce the diameter a bit. Well, now that I have a puck that's going to work, it's time to make it look pretty. So what I'm going to do here is I am going to take off all the rough oxidized levels of the aluminum, and I'm going to make the surface where the belt's going to fit on. You'll notice that there's I'm leaving ridges. I'm not sure if this is going to work, but well, from watching the videos that I've watched, I've seen that people have made all sorts of different kinds of well, basically dry wheels and idle wheels, and there's all kinds of theories out there of what texture they should have. Some think they should be sort of have a bit of a curve to them. I have no clue, but while I was watching these, I thought maybe the best thing would be for it to have, for the wheel to have a bit of a tactile quality to it. So I left, as you can see here, actually I don't know if I'm going to show it to you, but hold on a sec. Come on, turn it around. There we go. Yes, this bit of a ridge feel will give a bit more of a friction to the wheel, and hopefully it'll center and track better. If not, I'll be pulling these all off and making a fine finish on them. This is just to sand down the drive shaft to get it to where I want it to be. Well, actually mostly just to get the rust off so I can pound it on. I don't want it to be pounded on and then not be able to get it all the way on, because that would be bad. So a bit of sanding makes the fit just a little looser, and that'll allow me to be able to pound this on properly. But before we get to that point, we have one more step we need to do, just to be safe. And to make sure that this doesn't come off, I am going to make a keyway on this. I'm gonna drill a hole. Oh, yeah, sorry. I've never threaded it through in a limited space before, so I did a test piece here. I wanted to make sure my my tap would go through, and I would end up with you know, a hole that I can actually run a bolt all the way through. So I did a test piece here, and I didn't want to, after all this work, end up wasting this wheel. So here I have it set up in the vise. I've put two, well, popsicle sticks left over from when my kids were young, and we're going to drill a hole that I'm going to thread, and then I'll be able to put in a pin to hold it in that slot that's on the drive wheel. That bar that you see underneath is, well, in a lot of machining people use parallels to make sure everything's flat and where it needs to be. I find I just, because I don't need to be that accurate, all they did here was they used a piece of aluminum that's parallel for all intents and purposes because it's extruded. And what I've done here is I've already finished drilling the hole. Now I've done most of the tapping. I'm just showing you the last little bit. This video is getting a little long. I didn't want to waste too much time showing you everything. This is me just pounding it on. It was a very good friction fit. It took a fair amount of effort to get it in place, and I kept making small adjustments to make sure it was where it needed to be. Oh, and this part here, I threaded two. Sorry, it went way too fast. This part I probably shouldn't have been done in fast forward. That first threaded piece is actually aluminum. I threaded a piece of aluminum. I figured, see, now this is all aluminum. I should do one. But I couldn't get enough of a grip on it in the vise, so it just spun out of control. So I cut a bolt, basically a steel bolt, and I just put a threaded slot in it. So that's what I ended up using, because I was actually originally worried about the aluminum, the slot breaking as I was trying to screw it into place. So I ended up making two, and it turned out there wasn't even going to be a problem, because I wasn't even going to get to get into the part where I'll be able to tighten it down, because I couldn't hold it in the vise strong enough. And I'm just going to screw this in place, tighten it down, and then we're going to turn this thing on and see how it works. So this is basically going to be the end of this video. It's already long enough. The next video will be me making the 3 idle wheels with their bearings and everything. I'm not sure I'm going to be able to fit that all into one video, but hopefully that will all work out perfectly. And here we are, spinning nice and true and smooth. And I think that's about as best as I could hope for. Well, thank you for watching this video. It's, like I said, my first attempt at doing this sort of machining. Hope you enjoyed it, and in the next video we'll move on to the idle wheels, and then from there onto the framing and everything else. So thanks for watching again, and see you in the next video. Hey everybody, thank you for watching my video. If you liked it, please slap a like below, or if you want to see more of this type of video or some of my other work, please subscribe to my channel. And I will see you there. Thank you very much for watching. Bye for now.